You meet someone at a party. They tell you their name. You smile, you nod, you think to yourself, okay, remember that. And 30 seconds later, mid-conversation, it is completely gone. Not fuzzy, not on the tip of your tongue, just gone, like it was never there. You read an entire chapter of a textbook. You get to the end of it and someone asks you what it was about, and you can produce approximately one vague sentence that could describe almost any chapter of almost any textbook ever written. The specific content, the details, the examples, the arguments, completely absent. You study for an exam, hours of it, you go over the material repeatedly, you feel like you know it. You sit down in the exam room, read the first question, and your mind presents you with a perfectly blank white wall where the answer is supposed to be. You walk into a room and forget why you went there. You forget to reply to messages you genuinely intended to reply to. You forget things people told you days ago that were clearly important to them. And somewhere along the way, you arrived at a conclusion that feels increasingly certain and increasingly damaging. Your memory is just bad. Some people have good memories and you don't, and that is simply how it is. That conclusion is wrong, completely, scientifically, demonstrably wrong. And the evidence against it is some of the most fascinating neuroscience produced in the last 30 years. Your memory is not bad. Your memory is extraordinary. The human brain's long-term memory capacity has been estimated by computational neuroscience researchers at approximately 2.5 petabytes, roughly equivalent to 3 million hours of video storage. You are not working with a broken hard drive. You are working with one of the most sophisticated information storage systems ever produced by biological evolution. The problem is not storage. The problem is encoding. You are putting information in the wrong way, through the wrong channels, without the biological signals that tell your hippocampus, your brain's memory gateway, that this information is worth transferring to long-term storage. And when the encoding is wrong, the storage never happens, not because you lack capacity, because the information never made it past the gate. Fix the encoding and the memory follows automatically. That is what the Memory Encoding Protocol does. 5 levels of encoding, each one deeper, each one more durable, each one activating a different biological mechanism that your brain uses to decide what gets kept and what gets discarded. By the end of this video, you will never think about memory the same way again. Let's build the system. Why your brain forgets. The neuroscience of encoding failure. Before we fix the problem, we need to understand it precisely. Because encoding failure is not one thing. It is several different failures happening at different stages of the memory formation process, and the fix for each is different. Your brain processes incoming information through a series of stages before anything reaches long-term memory. Sensory input arrives first, what you see, hear, or read. This sensory information enters working memory, your brain's temporary processing workspace, where it is held for active, conscious processing. Working memory has a limited capacity, approximately 4 to 7 distinct items, and a limited duration. Information that is not actively processed typically fades within 15 to 30 seconds. For information to move from working memory into long-term memory, it must pass through the hippocampus, a seahorse-shaped structure in the medial temporal lobe that functions as the brain's memory consolidation gateway. The hippocampus evaluates incoming information against a specific set of biological criteria and makes a largely automatic decision about whether to initiate the process of long-term potentiation, the strengthening of synaptic connections that constitutes the physical formation of a long-term memory. The criteria the hippocampus uses for this evaluation are not the criteria most people assume. It does not prioritize information based on how long you looked at it, how many times you read it, or how sincerely you told yourself to remember it. It prioritizes information based on 3 primary signals: emotional significance, meaningful connection to existing knowledge, and evidence of active retrieval demand. Information that scores high on these 3 signals gets consolidated. Information that scores low gets discarded, regardless of how much time and effort you invested in trying to remember it. This is why passive rereading is one of the least effective study methods known to cognitive science. Rereading generates none of the three consolidation signals. The information is familiar, so there is no emotional novelty signal. It is not being actively connected to existing knowledge, so there is no elaborative encoding signal, and there is no retrieval demand. You are receiving the information, not pulling it from memory. The hippocampus sees low-priority material and files it accordingly. In the trash. The Memory Encoding Protocol is designed specifically to generate all three consolidation signals for every piece of information you want to remember. Here is exactly how. The Memory Encoding Protocol, 5 levels. Level 1, Attention Priming. Open the gate before information arrives. The first and most fundamental encoding failure is the one that happens before you even begin trying to remember something. You are technically present for the information. Your eyes are moving across the page. Your ears are hearing the words. But your brain is not actually processing the incoming information with the attentional resources required for hippocampal encoding to begin. This is called attentional encoding failure, and it is responsible for the majority of everyday memory lapses. Forgetting names, forgetting what you just read, forgetting the things someone told you 10 minutes ago. The information arrived, your sensory systems detected it, but your attentional system, your prefrontal cortex's capacity to select specific inputs for deep processing, was directed elsewhere. The hippocampus never received a signal that this information was worth processing, so it wasn't. Here is the mechanism. Your hippocampus can only consolidate information that your prefrontal cortex has flagged as attended. Attention is the gate. Without attention, nothing passes through to encoding, regardless of how many times you expose yourself to the information. The fix is what cognitive scientists call intention-based attention priming. Before receiving information you want to remember, you explicitly set an encoding intention, a specific, conscious declaration that you are about to receive information you intend to retain. I am going to remember this person's name. I am reading this chapter to understand and retain the mechanism of X. I am listening to this conversation to extract the 3 key points. This deliberate intention activates the prefrontal cortex's selective attention circuits in the specific direction of the incoming information. It tells the hippocampus, before the information arrives, that this is high-priority material deserving consolidation resources. Studies from cognitive neuroscience show that intention-based encoding produces measurably stronger memory traces than incidental encoding, meaning information you deliberately intend to remember is encoded more deeply than information you encounter without explicit encoding intent, even when the exposure duration and content are identical. Implementation. Before reading, studying, or any situation where you want to remember what you encounter, spend 10 seconds explicitly stating your encoding intention. Say it in your head or on paper. I intend to remember X from this. The gate opens, the hippocampus prepares, the encoding begins before the first piece of information arrives. Level 2. Elaborative encoding. Connect new information to what you already know. Attention gets the information through the gate. Elaborative encoding is what determines how deeply it gets stored once it's inside. Your brain does not store information in isolation. It stores information as a network of associations, each new piece of knowledge physically connected to existing knowledge through synaptic pathways in the neural network. The more connections a new piece of information has to existing knowledge, the more retrieval pathways exist for accessing it later. Information with many connections is easy to retrieve. It can be reached through any of its multiple pathways. Information with few or no connections is difficult or impossible to retrieve. It exists in the network but has no pathways leading to it. This is why domain experts remember new information in their field so much more easily than novices. It is not that experts have better memories. They have denser existing knowledge networks. Every new piece of information has dozens of existing connections available to anchor to. The novice's network is sparse. New information has few anchor points and encodes weakly as a result. Elaborative encoding is the technique of deliberately creating connections between new information and your existing knowledge at the moment of encoding. Instead of passively receiving a new fact, you actively ask, what do I already know that this connects to? How does this relate to something I understand? What does this remind me of? What does this contradict or confirm from what I already know? Each question you ask and answer generates a new synaptic connection between the new information and your existing network. The more questions, the more connections. The more connections, the more retrieval pathways. The more retrieval pathways, the more reliably you can access the information when you need it. Implementation. After reading each paragraph or section of material you want to remember, pause for 30 seconds and ask 2 questions. First, what does this connect to that I already know? Second, can I explain this in my own words without looking at the text? The act of connecting and translating activates elaborative encoding and generates the associative network that makes the information retrievable. This 30-second pause per section will feel like it slows your reading. It will triple your retention. The math is not close. Level 3. Emotional tagging. Make the brain care about the information. This is the encoding level that explains why you remember certain things from 10 years ago in vivid detail, while you cannot remember what you had for breakfast 3 days ago. And it is the level that most study and memory advice completely ignores. Your amygdala, at the brain's emotional processing center, has a direct modulatory relationship with your hippocampus. When your amygdala detects emotional significance in an experience, surprise, humor, fear, wonder, personal relevance, strong aesthetic response, it sends a neurochemical signal to the hippocampus that essentially says, "This one matters, encode it deeply." The hippocampus responds by initiating a more thorough consolidation process. Stronger synaptic potentiation, more extensive associative network formation, more reliable long-term storage. This is why emotional memories are so vivid and durable. And it is why emotionally flat information, the dry facts, abstract concepts, information presented in a neutral, affectless way, encodes so poorly by default. Your amygdala sends no signal. Your hippocampus receives no priority instruction. The material goes into shallow encoding that fades rapidly. The solution is deliberate emotional tagging, consciously attaching an emotional response to information you want to remember at the moment of encoding. This can be done in several ways. Finding the genuinely surprising or counterintuitive aspect of the information and allowing yourself to feel the surprise. Wait, that is genuinely fascinating. Connecting the information to something personally relevant. This directly affects how I approach X in my own life. Creating a vivid, exaggerated, ridiculous mental image associated with the information, humor, and absurdity are particularly powerful emotional tags because they are both novel and personally generated. Or finding the human story behind an abstract fact, personalizing the information by imagining the person who discovered it, the context in which it matters, the real-world situation it describes. Implementation. For every piece of information you want to encode deeply, spend 15 seconds asking, what is genuinely interesting, surprising, or personally relevant about this? If nothing comes immediately, create it. Invent a ridiculous mental image, find the human story, connect it to something in your own experience. The emotional tag does not need to be profound, it needs to be genuine. A small, authentic reaction encodes more deeply than a large performed one. Level 4, retrieval practice. Pull the information out to lock it in. This is the most research-supported memory technique in cognitive psychology and the one most consistently absent from how people study and learn. Active retrieval practice, deliberately pulling information from memory rather than passively reviewing it, is not just a way to check what you know. It is the primary mechanism by which long-term memories are strengthened and made permanently accessible. Here is the neuroscience. Every time you successfully retrieve a piece of information from memory, the synaptic pathways associated with that memory undergo a process called reconsolidation. They are temporarily destabilized and then restabilized in a strengthened form. The act of retrieval literally strengthens the memory. Each successful retrieval makes the next retrieval faster, easier, and more reliable. This is why retrieval practice is sometimes called the testing effect. Being tested on material produces stronger memory than studying the same material for an equivalent time period, even when the test is done before the material has been fully learned. The counterintuitive implication is profound. The struggle of trying to retrieve information, the effortful, uncomfortable process of searching your memory for something that does not come easily, is not a sign that learning has failed. It is the mechanism of learning. The struggle is the encoding. The difficulty of retrieval is what makes the memory stronger. Every time you successfully pull information from memory, despite the difficulty, you have just made that memory more permanent than any amount of rereading could have done. Implementation. After every study session, learning period, or reading block, close all materials and spend 5 to 10 minutes attempting to recall everything you just encountered. Write it down, say it out loud, teach it to an imaginary student. The specific format matters less than the act of active retrieval without reference to the source material. Then check what you missed. The items you could not retrieve are precisely the items that need another retrieval practice cycle, not another rereading. Use spaced repetition to schedule your retrieval practice sessions. Review material at increasing intervals, day 1, day 3, day 7, day 14. Each spaced retrieval session strengthens the memory further and extends the interval before the next review is needed. Level 5. Sleep consolidation. Let the biology finish the job. The final level is the one that happens while you are unconscious and the one without which all 4 previous levels produce memories that are significantly less durable than they could be. During slow-wave sleep and REM sleep, your hippocampus replays the neural activation patterns from the day's learning experiences, a process called memory consolidation replay. During this replay, the information encoded during waking hours is transferred from hippocampal storage, temporary, fragile, capacity limited, to cortical storage, permanent, stable, essentially unlimited. The synaptic connections formed during the day's encoding are strengthened and integrated into your long-term cortical network during sleep in a way that cannot be replicated by any waking hours technique. Research from Harvard's Sleep and Cognition Laboratory shows that a full night of sleep following a learning session produces 20 to 40% better retention of that material compared to the same learning session followed by a period of wakefulness of the same duration. This is not a small effect. It is the difference between remembering and forgetting. And it means that cutting sleep after an intensive learning session, pulling an all-nighter before an exam, staying up late to get one more review session in, is neurologically counterproductive. You are sacrificing the biological process that would have made your learning permanent in exchange for more time, doing the very thing that only becomes permanent during sleep. Implementation. Treat sleep as the final and essential step of every learning session. Protect the sleep window following intensive encoding the same way you protect the encoding session itself. Where possible, schedule your most important learning in the late afternoon or evening so that sleep follows it relatively quickly, within 4 to 6 hours, giving the consolidation replay process maximum proximity to the encoding. And implement a 10-minute review of the day's most important learning material immediately before sleep, not for encoding additional content, but to prime the consolidation replay process with the most important material you want your sleeping brain to strengthen. If your understanding of memory just fundamentally shifted, hit that like button and tell me in the comments. What is the one thing you can never seem to remember, no matter how hard you try? Drop it below. Your Memory Encoding Protocol cheat sheet. Level 1. Attention priming. Set an explicit encoding intention before receiving information. Open the hippocampal gate deliberately. Level 2. Elaborative encoding. Connect new information to existing knowledge immediately. Ask what it relates to and translate it into your own words. Level 3. Emotional tagging. Find what is genuinely surprising, personally relevant, or absurdly memorable about the information. Give the amygdala something to signal the hippocampus about. Level 4. Retrieval practice. After every learning session, close all materials and pull everything from memory actively. Schedule spaced retrieval sessions at increasing intervals. Level 5. Sleep consolidation. Protect the sleep window following learning. Review key material immediately before sleep to prime consolidation replay. Your memory is not broken. It never was. It is a staggering biological system that has been given the wrong input format for your entire learning life. Nobody taught you how to encode. They just told you to study more. And studying more without fixing the encoding is like pouring water into a sieve and being confused about why nothing stays. Now you have the encoding system, 5 levels, each one targeting a different biological mechanism, each one compounding the effect of the others when used together. Apply all 5 to your next learning session, and you will feel the difference before the session ends. Apply them consistently for 30 days, and people will start asking you how you remember so much so easily. The answer is simple. You learned how to save the file correctly. Everything else is just biology doing what biology does. Like this video, if your memory just got a serious upgrade. Subscribe, because next week we are breaking down the 90-minute focus system used by the top 1% of performers, and why the way you are currently scheduling your work is costing you hours of productive output every single day. That one is going to restructure your entire day. Let's go.